In this video, we're going to talk about rational equation applications, specifically rate problems. So let's take our first example. A small airplane flies 810 miles with an average speed of 270 miles per hour. 1.5 hours after the plane leaves, a Boeing 747 leaves from the same point. Both planes arrive at the same time. What was the average speed of the 747? So we need to identify our known and unknowns from that problem. We know that we're going to use the distance equals rate times time formula. We know they traveled the same distance of 810 miles. The small airplane's speed was 270 miles per hour, and it took them an hour and a half longer to get to the destination than the 747. So we can rewrite our formula for t, so we would have time equals distance divided by rate. So we set the times equal to each other, and we need to adjust for the 1.5 hour difference. So I have the time of the airplane is equal to the time of the 747, but I had to add an extra 1.5 hours to the 747 because the airplane took longer to get there. So its time would be a larger number than the time of the 747. So to make the two numbers equal, I have to add 1.5 hours to the smaller number. I could equally have done this problem by subtracting 1.5 hours from the time of the small airplane. Either way will get us to the same answer. So as we fill in what we know, we get our equation. Our airplane is 810 over the rate of 270, which is equal to the 747, 810 miles divided by its speed, plus the 1.5 hours time. So now we're going to go through and solve this. Now, since 810 can be divided by 270, I'm going to go ahead and work that out first. So this is going to get me 3 is equal to 810 over x plus 1.5. So nicely I can just subtract 1.5 from both sides. So now I have 3 minus 1.5. So we now have 1.5 is equal to 810 over x. Now I'm going to cross multiply. And I'm going to get 1.5x is equal to 810. Now I'm going to divide both sides by 1.5. And so my speed is going to be x is equal to 540 miles per hour. And that's the speed of the 747.